Hang on for the ride. You guys ready? All right, here we go. So, yesterday we talked really briefly about how, hey, at the beginning of section 1.10, regressions come back. And if regressions come back, question, what does that technically mean? What else has to come back? Tables, right? So, real quick, some of you hopefully started homework last night. And if not, maybe you remember from the graphing calculator handbook that you still have and you can still reference. How do you make lists in your calculator? Okay, good. Stat edit. Put in the list. List 1, list 2. Why do you think they made x equal to 3, x equal to 4, etc., even though they didn't specifically say so? Why would that have been a good idea for this example? It was a personal choice I made. Why would I make 2003 3 and 2004 4? Yeah, remember? If 2003 was your x, where is all my data on my graph? So what am I saying instead? X measures the number of years from 2000. So I'm just measuring from 2000 instead of measuring from 0 AD, right? After you put the lists in, then they say construct a scatter plot. How would you do that? Walk me through. Yeah, you could just from the y equals go up and turn on plot 1 as long as you did list 1, list 2. But what zoom would you want to use? Because the x's aren't bad. The x's are like, yeah, it's going to be in my zoom standard, but the y's aren't. So what zoom is helpful? Zoom stat will go find the data for me. That's how I make a scatter plot. The other way of doing it, older calculators, you have to do second y equals, turn on the stat plot. Second y equals, turn on the stat plot. And then what did they say to do? Find the least squares regression line. It's stated strangely, but you guys wrote it in your notes technically. What is the least squares regression line? It's just the line of best fit. And what feature do we use for the line of best fit? What do we use in the graphing calculator handbook? Just use the regression. Just use the linear regression. Colby, we good? Okay. So, even though they might say the least squares regression line, even though they might say the line of best fit, I'm just trying to let you know all the different synonyms for the linear regression that we learned how to use in our calculator handbook. Does that make sense? Technically, there are special things about the R values. In the newer calculators, you see some of that because they don't just give you the regression. They actually talk about this R thing as well. Older calculators don't, so I don't really stress about it because this is not a statistics class. If it was, we would need to go into how good of a fit is it, but we're not stats, so I'm just saying, like, hey, that's a thing. The R that's in there, some of you guys have been wondering what he is. He actually shows how well the line fits the data, but that's not really something we're going to stress about. So when you get the linear regression, you guys know what to do, right? I went ahead and already put it in before I showed the scatter plot, and then I saw the linear regression, or I solved for it using, what would that have been? Stat calc, right? Stat calc uses the lim-reg feature. They give you this equation. We did our graphing calculator handbook. Let's not spend any more time on it besides the fact or the question, does this line perfectly go through all the points? No, because that's not what it's supposed to do. It takes all the data and in a sense it kind of averages it in order to figure out in general what the trend is. So that R is saying, hey, some of that data is a little bit off, but as you guys can tell, this is a pretty good fit to the data. Yeah, because the data was pretty stinking linear. It's not perfectly similar, above and below doesn't perfectly go through, but it fits the data very well. Which, going back to that R, just in case you're curious for when it shows up on the newer calculators, R would have been pretty stinking close to 1. The closer R is to 1, the better the fit. The farther R is away from 1, if R was like 0.1 or 0.2 or 0.5, the data would have been scattered all over the place and not on the line. All right, so that's all regression-y stuff. I think that's where homework starts, but you guys are used to that. You saw it in the handbook. Go back to the handbook if you need help. Ask me if you're still stuck on the regression stuff. But otherwise, we need to get into the other types of problems you're going to see. And I think in homework, for those of you that started, wasn't there a clear switch? Like there were tables, and then all of a sudden it was just like words for the rest. So, what do we do with the words? If you see direct variation, or varies directly, or directly proportional, aka if you see direct in some way, shape, or form. I need you guys to think of y equals kx. And you've seen this before, direct variation, inverse variation. K, we just call it a constant of variation. So y is our dependent variable, x is our independent variable. It doesn't have to be a y, it doesn't have to be an x. But we have an dependent, we have an independent, and we have some sort of constant. So you guys read simple interest is directly proportional to the amount of the investment. If I want you to make or to form an equation that models the data, remember this title of this section is called math modeling or mathematically modeling. The very first thing you have to figure out is, well, okay, they didn't give me any variables, so I get to make my own. Could we use y and x? What might be a little bit better for simple interest than y? You need to be creative. What would be a better variable for simple interest than y? S, sure. Or you could do I, but some of you looked ahead and said, I think I'm going to use I for investment. Or maybe in money, some people might use P for principal instead of I for investment. But either way, we could use I for investment. Using capital I, little I looks imaginary. Simple interest, sure, we would use S. That's what we chose, but other people probably would use I for interest and P for principal as in the beginning money amount. Either way. So if I want to make an equation, simple interest is, so S is always a mathematical term for what? Equals. Directly proportional, oh hey, you have a constant times, who? The amount of the investment? So as simple as S equals K times I. That's where you would start, and if it gave you more information, you would go plugging in, maybe finding K, then maybe plugging in some more and finding a particular simple interest or a particular investment. Then on the second example, what do you guys say? This time they give us variables, we don't get to choose. What would the equation be? Close. S does equal K times something. I gotta read the directions. The square. That's one thing. Does that make sense? Gotta read carefully. This is S. Okay, use S. Varies directly. Okay, so equals K times. That's that varies directly relationship. And then the square of the duration T squared. Is that how easy homework is? Not even close. But that's the beginning. Inverse variation. We have I think 4. We have direct, we have inverse, we have joint, and we have, ooh, what's the last one? Joint? Combined? I think it's combined. Inverse variation. You guys can summarize these notes if you want. Long story short, we have some synonymous phrases for inverse variation. Varies inversely, inversely proportional to. The relationship that we'll see is K divided by. You've probably heard direct and inverse variation. Well, you might have heard it this way in the past. Direct is if Y goes up, K goes up. Inverse is if Y goes up, K goes down. As you guys are writing, let's see. What's a real life example for direct besides the ones you've already seen, like interest and distance? Direct. If one goes up, the other goes up. Sorry, I have an example for inverse in my head. I was thinking money ones, but we already have money ones. Okay, here's one. Although it's not necessarily always true, it's usually true. In most jobs, with some sort of pay scale, pay grid, maybe I can't actually say that. In some jobs, with a pay scale and pay grid, usually a big company, corporation, public school district, etc. The more years you are on the job, what happens? So the more years, the more time you're on the job, the higher your salary. Now I said some jobs. That is not true everywhere. It depends on how small your business is as compared to other there's a pay scale, if there's a pay grade. Usually, the longer you work, the more your pay goes up, right? Which is why, it's kind of sad, this is why some jobs have unions, because if they didn't have unions to protect workers that have been on the job a long time, which is super dangerous in some ways and super not good in other ways, but the reason they are good is, what would, just to save money, what would the different corporations or companies or public school districts do to those who have been on the job for a really long time if they need to cut their budget and need to save money? Fire all the people who are making tons of money and hire new ones who will go in at the starting rate. Yeah, that would save money, right? Now the problem is they lose all the experience. And our unions totally good if we're just talking about life. If people feel totally comfortable in a job, like they could never get fired no matter what, is that a safe thing? No, because what's going to happen to their work ethic unless they are a person of immense integrity? They're going to be like, whatever, you can't fire me. And believe it or not, public school districts, there are a lot of teachers that are whatever, you can't fire me. Not a lot as in the majority, but there are some that literally the school cannot get rid of, even though everyone on staff knows that they are ineffective and they actually hurt the students more than help them. Because the teacher union won't let you fire them. Interesting. Unions, good and bad all at the same time, but this is not history or government or anything else. Let's come back. Or business or econ. Okay, that's a direct. The more years on a job, usually your pay goes up. Okay. Inverse. We'll go back to the Frappuccino one. I think I used this one earlier. If temperature goes up, what happens to the temperature of your, if the temperature outside goes up, what happens to the temperature of your Frappuccino when it's sitting out in the sun? It goes down. Inverse relationship. As one goes up, the other goes down. We could also talk about. Oh, whoa. Yeah. That's awkward. That doesn't work either. Oh, hey, inside my room. There you go. As the temperature outside goes up, what happens to my room? It goes down. There you go. That works a little better. It's still awkward. Isn't this wrong? It's super hot. It just randomly gets cold, so that relationship is not totally true. But when it gets cold and rain, people randomly get cold here too. So what's going to go on with the demand for a product varying inversely with the price? Ooh, this is a great one. Econ 101. If the price goes up, the demand goes down. Not usually. If the price goes up, the demand goes down. Why? Not everyone's willing to pay a higher price. So does that mean that people still, like if the price goes up, do people really want it? Yes, but the demand is what they're actually buying. So as the price goes up, what people are actually buying goes down. Okay, how do you make this as an equation then? D? Sure, we'll call demand D. D equals what? Sure. Sounds good. You can make up your own variables, but demand is or varies inversely with price. That wouldn't necessarily be the variables that anyone would use or everyone would use, but this economic principle is an important one. Ooh, then we can talk about supply and demand, but that's not this class. Combined variation. There's no formula, because it just means there's a little bit of everything going on, direct and inverse. Combined variation. Snazzy math way of describing direct and inverse relationships going on. Now guys, have I been giving you tons of time to write down these big paragraphs and sentences of words? Okay, maybe I kind of have, but not on purpose. Am I going to keep giving you tons of time to write down the big old paragraphs? No. Why? Because you're supposed to be reading, analyzing, shortening, giving the short, sweet version of what's going on, right? And hopefully that is the first step in getting towards the equation. Because if you're an electrician, is it kind of important to know copper wire maybe versus another wire? Yes. But otherwise, for our purposes, we really just care about the word. Well, I was going to say resistance. Other copper wire is just a prepositional phrase qualifying the resistance, right? Ooh, grammar, that's fun. Resistance, actually other copper wire carrying an electrical current, is all extra information for our mathematical modeling perspective. So if you guys are writing down the example, hopefully you write resistance is directly proportional to length, comma, inversely proportional to cross-sectional area, or even just area. And if you're able to pick out you just write those words, don't you basically have an equation just waiting for you? Any word problem, you gotta pull out the important information for our for our math modeling of the situation that we're going to be using for the rest of the time. So, resistance, what do you want to call it? R. Sounds good to me. Is directly proportional to K times L. And inversely proportional, pause, where's the K?
Over.
Inversely means over. Eric, my question to you is K times L and over A all at the same time? Yeah, but it's awkward. Wouldn't it be a lot nicer just to go ahead and write it as? Wouldn't that just be L over 1? So it's not just the same thing as K times L and all over A at the same time. So you could think of it as K over A and K times L. K is what's in common. Direct is going to be multiplied. Inverse is going to be divided. I think that's a lot easier just to go ahead and put it all together. Okay, so far I'm just working on translations. That's mathematical. Translating the words into mathematical statements, not as in shifting a graph. Okay. Joint variation. Once again, as you guys are writing, get the short and sweet of it. P.S. Being able to read while looking for the key pieces of information that you need to hold on to is helpful in almost any field of study. Not just math. Not just English and reading comprehension. Not just for tests and quizzes or SATs and ACTs. A lot of math is learning how to process information, which is important wherever you go and whatever you do. Very few of us can hold on to the full information that we're given. Most of us need some way of making it short and sweet in order to hold on to it. Study it, to memorize it, to use it. Just random. Okay. Joint variation, it could be said, it could be stated as, varies jointly or jointly proportional to. You guys are seeing a lot of those different synonyms multiple times. What do you notice about the equation? Joint variation is very similar to direct variation, except, in a sense, it's direct variation with multiple constants. Does that make sense? Direct variation, K times, I say constants, I apologize, multiple quantities, multiple variables. So it doesn't just depend on one, it depends on multiple lengths. Well, the popular formula, which I could just say one way, but I'll say the other way. Kinetic energy E of an object varies jointly with the object's mass and squared with the object's velocity v. What formula am I talking about? Yeah, kinetic energy, so E equals, because it's, right, pull out. So we have our E, we have our varies jointly, so that's going to be with multiple things, but we know it's direct variation, right? With mass, odds. Ooh, if I just think that, I'm going to, so be careful. Reading comprehension, yes, it's good to be able to shorten, but if you leave off an important detail, you're going to miss everything else. So the squared velocity, so we have mv squared. I guess most of you guys. How many of you guys are in physics? Anybody? AP or by year? Is it this period? It might be. Oh, it is this period. Okay. So, wait a minute. Are we all done with notes? Yes. So how does homework get hard? Must be in the problems. You ready? This one's an easy one. What do you do after you're able to translate, or after you know how to translate, which hopefully you just figured out from the direct, the inverse, the joint, and the combined. Oops, sorry. Combined and joint. You gotta actually translate and use the model that you make. So number 25. Just different examples pulled out from homework exercises. Meaning all the possible, not meaning your actual problems. Only rarely do I do an actual problem that you might see in homework. Exactly the same. We gotta make a model, guys. Either they give us a model and we use it, or we have to make a model based on the information. So, what model can we make? Because I don't see an equation right now that I can use. Yep, very directly. This should lead you to y equals kx. However, what did they give me up here that I'm supposed to come back and look at? Clues. And if you want to lose clues, that's why I'm putting it off there. Clues. I'm supposed to use them. They gave me s equals 4 and y equals 8 pi. So what do I do? Yeah, as easy as that. Take the clue, plug it in, so you end up with 8 pi. Exactly. Is when x is 4, but I'm solving for. They didn't tell me solve for k. They just said solve for the model, but I was missing this piece to my equation. So I plug in the particular piece of information. Hopefully you guys know I solve for k by dividing. I get k equals 8 pi over 4, which means k equals 2 pi. Oh, look, I'm done. No, that's just k. Solve the model is, what is the entire model for this situation, for this scenario? Y equals 2 pi x. K was just one little piece of that. Very important. Just a piece nonetheless. They want to solve the model. They want me to go ahead and figure out what is the equation with the constant solve for. Does that make sense, guys, what they're saying and how the directions are working? I know, it's cold. Hang in there. Now what? Ooh, they just gave me points. I could plot them. I guess I could plot them and actually calculate. That takes too much time. Aren't both of these parent functions? What would this guy look like, roughly? A line going through 0, 0? Some sort of slope. Up if k is positive. Oh, you're already looking at the data. Hold on. What's the other one look like, the other parent function? It's over x. You remember what 1 over x looks like? Yeah. Either way, going down with different directions depending on what's going on. One has more of a curve, one is more linear. So far, what I've heard is, hey, it's going up. Which could be that one, but this one could also be going down if k is negative. Could be this one. But maybe if I was to flip it, oh yeah, maybe it's not that one. I have to figure it out based on the positives or the negatives of the k's. But what else do we need to look at besides the fact it's going up? The variation, not just of the x's, but of the y's. So as the x's steadily increase from 5 to 10 to 15, etc., I don't think we'll need as many points as they gave us. The y's, how do they increase? Constantly. What is the only graph that has a constant rise over 1? Something linear. something curved is increasing by or decreasing by, I should say in this example, decreasing by different amounts, decreasing by a lot and then a little and then a little bit less and a little bit less. The only type of function that has a constant as x goes up, y goes up is going to be a line. So we know it's going to be direct variation. Only linear functions, as x goes up to set constant, y goes up to set constant. So how am I going to actually find the model? You can either plug in, or you can be super snazzy and say, I know how to find the slope between 2 points. It's up to you. Because it is direct variation, because it's just linear, it's not like a squared or a cube, you could go ahead and actually find rise over run. But just to model, what if it was a squared or a cube? Yes, we would go ahead and plug in. Just pick a line, pick an x. Does it make sense that 2/5 is my slope? As you go up 2, you go over 5, and up 2, over 5. Pretend that my graph is actually lined up at all. I want the model, so therefore, not too bad, right? Fairly straightforward. Got to figure out the model, got to plug in what we know. Maybe not all of it. I only had to plug in one. Solve for what we don't know, and then have a complete model. Whether we end with the model or whether we keep going depends on the problem. So far, even for this one, all we're doing is finding models. Just for sake of simplicity, I'm going to go ahead and make this all black, just so that we can tell the black from the red. This is the problem. That's in help. In general, once my air gets going, it takes a while to turn off. That's just the way it works. So on hot days, it makes it really nice because it's really hot. And it's like, oh, turn on, and that takes a while to turn off. On cold days, if it does get turned on, usually there are lots of kids in the room. Like in period 2, there was a lot of kids in the room, so it thought it was normal. It turned on, but it just keeps going. Regardless of temperature, it must be on some sort of preset. Makes it nice on hot days. Just for sake of simplicity and for letting you guys kind of know what usually goes on, I'm going to go ahead and call the investment P. I know that I let you guys make your own variable before. Usually P stands for principal. Principal stands for some amount of money that is being put in for the principal amount of their account. So even though they call it an investment, because it is an investment, I almost always stands for interest whenever you're dealing with finance or financial information. So what would our model be, cool kids? P.S. Do you need your calculator? Yeah. If you don't have it, grab it out. They're decimals. We're not doing this by hand. We could, that'd be fun and all, but that's not. Okay, what's my model? Remember, keep your constant proportionality, right? It's just K, and K times 2, P. So we have our simple interest, so I call him I. Equals K times all him P, right? So you guys plug in as I speak, hopefully. Hopefully it's 11.25. Why is K going to be a tiny number? And it's a percent, right? A percent of interest. You guys have heard of like APRs and more, well, maybe you haven't, but different percentages on loan or credit card paybacks, or if you're looking to buy a new car, you do a percent as well. So the rate is a percent. A percent is going to have 2 decimal points over. When you divide both sides by 6,500, you got K is equal to point. 0.25. Can you give me one more? Okay. Okay, so that's even. So then can I say that interest is equal to, they just say solve for the model, 0.0325 times P? Yes. Or apply, could you say I is equal to 3.25% of P? This would be more analyzing, more actually stating what's going on. It's 3.25% return. The left side would definitely be more mathematical than 0.0325. But it makes sense that it's a little baby decimal because most investments, well, your return is actually probably a bit smaller than that. Most investments. Most steady investments, not like stock market investments. Is it really that easy? Someone who started homework last night. Did it get rough? Let's go find one where it got rough. You want to go peek at a hard one?
Yeah.
What's the one that has to do with the frequency of the middle, was it A string? Did anybody find that one? It's about plucking a string. I think it was a middle E or a middle A. I don't remember what was going on in the problem. Yeah, if you want to. That's where I'm going to put it. Yes. It was just that one time where I was like, it's not important for the quiz. No, it's a good question to ask. I'm glad you did. Somewhere around here, Newton's law of cooling. I don't remember which problems you had, but I know it gets tricky right around there. Because, guys, 41 through 46, isn't that just making an equation, right? But then all of a sudden it's like, well, bam. Okay. 49. Oh, that's not too bad. Hold on. Maybe that's not what I'm looking for. Where's the string one? Force, interest, measurement. Ooh, pause. I have you guys write directions and problems, right? So if you get to number 67, you're like, what's my model? What should you have done? And what do the directions say? Hey, there's a thing called Hooke's law. And guess what? The model for Hooke's law is distance. That's for you stretch or compress. Varies directly as the model is in the directions that you should have written. But to write the directions, couldn't you really just write a formula? And just call it Hooke's law and be super snazzy? Cool. Then you can use it in 67 and 68. Anyway, I want to show you guys that one. Did anybody figure out the whole tension on the spring? Or the string? Music! Here it is, number 72. Oh, Kobe, it was you. You should have figured that. Number 72. We were working on this one yesterday. The frequency of vibrations on a piano string varies directly as, okay, hold on. Writing the problem. You guys don't want to write all these words. No. Tell me the model this is giving you. Yes, in your notes, you might want to put number 72 or whatever we show. Frequency, F. Varies how? Okay, so K times the tension. Careful. That look good? The middle A string has a frequency of 440 vibrations per second. Anybody watch those like a mathematical and how we cut it in half and cut it in half and octaves? Music is very mathematical. Math is very musical. Anyway, coming back. How do you use that 440 thing? Because that's, I don't know. Well, there is no X. That's not good. It is the F. So I could say 440 equals K times his tension over his length. But then all of a sudden we're talking about somebody else. Find the frequency of a string that has, 1.25 times as much tension. Well, now there's a whole other equation. of another note with, oh, how much tension? 1.25 as much tension as this guy, and 1.2 times as much length as that guy. So these L's talk about the same thing. This L is the L of middle A, this T is the tension of middle A. Steve, hold on, I'm missing 1, 2, 3, 4 variables. How am I going to solve with only 2 equations? Like, how are you going to plug it in? Can I rewrite and say this little equation is the same thing as square root of 1.25 times k square root t all over 1.2 times L? Am I allowed to split up square roots when there's multiplication going on? Yes. Addition, subtraction? No, I'd be killing something. Where is it? A puppy technically. Because in this multiplication, I can split those two up. What do you guys notice? What's this? K and L and T all go away. 440 comes in. The square root of 1.25 and the 1.2, the tensions are going to be related. I just needed to figure out how using the formula. So, the frequency of the old one times square root of 1.25 divided by 1.2 ends up giving me the frequency of the new one. Don't be scared by there being a lot of variables. Maybe there still is a very legal math way of solving despite. Interesting. So how do you finish number 72? Plug it in, 440 times the square root of 1.25 divided by 1.2. The frequency of the random new string, but I don't know what it is. You would need to play it, and then you could hopefully identify it. Yeah, there you go, that'll work. And figure out how to do 1.25 times as much tension. Make it 1.2 times as long. I just don't know. Alright, that was one of the hardest ones in homework, and we still have 3 minutes. Let's check 1.9. Colored pens out. Nicely done, cool kids. We did it, so our calendar remains the same. Oh, party poopers. I showed you how to shorten writing all the questions tonight. And I did the hardest one. Monday's what? That's what your study said. Whoa, chapter 9. That's not good. Hold on. I don't know where I was going with that. Do cross country today, not tomorrow, right? And football's on Friday, so you have Saturday. All good things. Don't worry, tomorrow's going to be a work day. We're pretty much, hopefully, going to go over questions on 1.10 homework really fast. And we're just going to get out our reviews and our spirals and our books and just get going. And I'm going to be answering whatever you need. Okay? At the same time, you can have your notes up tomorrow, be highlighting anything that you're like, for this problem, I better study this part. Okay? Okay, 1.9. Number 2 is F inverse. That's the notation. Number 4, reflection across the y equals x line. Number 14, should they have both reduced to x? The answer is yes. The question is, were you able to do it? Quickly simplify, not quickly, sorry, carefully simplify. But yes, they both simplified to x. 20, were you just graphing? Oh. Oh, you were flipping it across the y equals x. So it should look something like that. And this was a lot like the one I did yesterday in class, but easier. You flipped that branch and then you flipped the other branch. 26. You guys did compositions once again. They did 2 different ways. I don't know. They were the same function. I feel like if you did it once, you would have known it would have worked the other way. But either way, 1 over just flips it, and yes, it's x. And this is like the one that we did in class yesterday, too. If you graph it, it is its own reflection. So that was okay. Yeah, it is its own inverse, ironically enough. 42, you were just graphing it again? Oh, you should have been able to visualize the graph. You didn't need to put it in your graphing calculator, did you? It's a parabola. It fails. Inverse function. Does it have an inverse relation? Yes. But they were asking about an inverse function. So if you put yes, just put relation in parentheses. And on the test, if you get confused and there is a question similar, be like, do you mean relation or function? I'll be like, good job, I mean this one. 52. It was another funky function where it was its own inverse. And if you graph it, hopefully you saw why. It was its own reflection as well. Domains and ranges, x can't equal 0 and neither can y, but if you flip it, still, it's just not equal to 0 for the domain and the range. (64). This is a key example. We wouldn't write f inverse because there are two different functions, so you can solve for the inverse, but there are two different ones. This is one of those, once again, it fails because it doesn't have an inverse function, but that is the inverse relation. Alright, okay, we almost got through checking 1.9. Oh, we did, that's 98. I will say questions on 1.9 and 1.10 tomorrow. Come and be ready. And if we have time to have a work day under review, the test will still be Monday. And if you're wasting my time trying to not have time for the test review tomorrow, I will. Bye, guys. But if we have time for our test review tomorrow,
We'll find a way. He is confident.
That's right. Here. They are because both of them. Aaron does his job, so hopefully he'll be able to finish it. We'll see. I'll be back. Thanks, kid.